We're solving problem 24 from the 2018 F equals MA exam A. A mass is attached to one end of a rigid rod, while the other end of the rod is attached to a fixed horizontal axle. Initially, the mass hangs at the end of the rod and the rod is vertical. The mass is given an initial kinetic energy K. If K is very small, the mass behaves like a pendulum performing small angle oscillations with period t0. As K is increased, the period of the motion for the mass A remains the same, B increases approaching a finite constant, C decreases approaching a finite non-zero constant, D decreases approaching zero, or E initially increases and then decreases. So the motion for something like this would be expressed in the form ml d squared theta over dt squared is equal to negative mg sine theta. However, we can approximate it to ml d squared theta over dt squared to be negative mg theta. So from here, since we basically just approximate this value because they're so close. So what we initially see is that through some thinking, we see that the period initially would increase if you increase the K. But because it increases when it swings up, when you add more force to it. But if you add enough force to make it go an entire loop, so if it goes like an entire loop, going like this way, then, the period would then decrease because at all points where you speed it up with more kinetic energy, the loop would only get shorter. It would only take less time to complete a loop. So therefore, our answer would be it initially increases and then decreases, or answer choice E, and that is our answer for this problem.